Welcome to the grand finale of WitBlox Young Inventor Techfest 2021 organized by IIT Bombay. Let's check out the journey of Samaira Gupta and Nysa from Mumbai.
Hi, I'm Nysa. I'm 15 and I go to St. Andrews International School, Bangkok. Some of my interests and hobbies include photography, guitar, golf, swimming, technology, coding, and designing, among many others.
Hi, I'm Samaira from grade 10. I'm 15 years old and I study at Abroad International School. I'm from Mumbai and I enjoy painting, art, music, sports, and I enjoy technology and coding.
Hello, I'm Nysa.
Hi, my name is Samaira.
Our project is about a retrofit autonomous mechanism for greywater separation and harvesting at the source.
Use of greywater is an important step for conserving water. The source of greywater separation has been the most important feature for an implementation. Our project, WasteWash, works to separate feces and urine at the source, which will prove beneficial for biological treatments. In addition to this urine, water has the largest proportion of nutrients, making nutrient recovery from urine more attractive, efficient, and easy, compared to filtering sludge that takes 3 to 18 days, yet ranging with an efficiency of 20 to 40%. WasteWash is a retrofit mechanism in the commode.
To achieve the project objective, we've developed a retrofit mechanism. It starts by detecting whether the waste is solid or liquid. The drainage pipe is divided into two with a mechanically sound mechanism as shown here. Sludge will be flushed into the drainage system while urine will be separated into another pipe and go through a 3-stage filtration process which separates it, and the water is then stored in a greywater tank. The system uses 3 DC water pumps attached to greywater, recycling, and normal tanks. This water is reused in a 70-30 ratio where the initial 70% of cleaning is done by greywater and the rest 30% is done by clean water. This allows water to be separated at the source.
The technology involved in the system includes a digital IR sensor to indicate the type of waste and an MP137 gas sensor to measure the intensity of the waste to rationalize the proportion of grey and clean water.
The prototype is designed and tested on 3D printed PLA parts which consume 12 volt and 2 amps of power. This system is driven by an Atmega 328 IC chip which works on embedded C programming. To understand the type of waste, we've developed our code using the PD proportional derivative method, and to understand the waste intensity, we've used a technique called RT versus FT.
The separation of the two streams at the source will increase the efficiency of the dewatering process and make it more cost efficient.